Now I'd like to go over some examples from 6.6, specifically using either the hinge theorem or the converse of the hinge theorem. So you want to replace each statement with either less than, greater than, or equal to, but then explain your reasoning as well. So on number 1, we're given that side AB is congruent to side DE, AC is congruent to DF, and then the measure of angle A is 35 degrees, the measure of angle D is 45 degrees. So two sides of one triangle are congruent to two sides of a second triangle. This angle of the second triangle is actually larger than the angle of the first triangle. So then what that means is the side opposite the larger angle, EF, is greater than or longer than the side opposite the shorter angle, side BC. So BC would be smaller than EF, specifically by the hinge theorem is the reasoning that we can use. Pause the video, maybe work through problem numbers 2 and 3, see if you could figure out the inequality. So number 2, two sides of a second triangle, one triangle are congruent to two sides of a second triangle. This angle is larger than this angle, so side BC has to be longer or greater than the length of side EF. And then on number 3, these two angles are congruent between the two congruent sides. So BC, even though it might appear that BC is longer than EF, these two sides are congruent, these two sides are congruent, these two angles are congruent. So the lengths of those two third sides would have to be equal. And then on number 4, let's continue with that. I have all three sides of this triangle congruent to all three sides of this triangle. So the measure of angle A compared to the measure of angle D. Angle A is opposite side CB, which is congruent with side EF, and that's the angle that's the side that's opposite angle D. So the measure of those two angles would have to be equal. And then the reasoning would be the converse of the hinge theorem. And then for number 5, maybe pause the video, figure out if you can see which angle is greater or if they're equal. So you have two sides of triangle ABC congruent to two sides of triangle DEF. Third side here is shorter than the third side here. So angle A has to be smaller than angle D. Measure of angle A is less than the measure of angle D. Okay. And then I do want to go over at least one other example. And then it said explain the reasoning for number 5. It would again be the converse of the hinge theorem. Okay. Number 7, take a look at that. Pause the video. See if you can figure out the length of AB compared to the length of AC. I still want to use either an inequality or an equal sign. Here's one thing that you needed to figure out in order to be able to figure out the length of AB compared to the length of AC. This side AD is congruent with itself. So I have two sides in the left side triangle or triangle ABD congruent to two sides of the triangle on the right or triangle ADC. This angle is greater than this angle. This is the included angle between the two congruent sides. So is this. This is a greater angle. So side length AB has to be longer, or the length is greater than side length AC.